In this video, I'm going to show you how we got the derivatives of all of the arcsine, arc cosine, arctangent, arc cotangent, arcsecant, and arccosecant functions. So, y is equal to arcsine of x. How are we going to derive this? How are we going to get this derivative? We're actually going to do it implicitly and using triangles. I'm going to change this to the sine of y is equal to x. Just by taking the sine of both sides, so the arc sine and the sine cancel out, sine of y is equal to x. Now what I'm going to do is I'm going to draw my triangle. Because this is x over 1 and y is the angle, the sine of y is opposite over hypotenuse. So the opposite side is x, the hypotenuse is 1. So using Pythagorean theorem, I would get the third side to be square root of 1 minus x squared. So now what I'm going to do is, so I've got my triangle set up. Now I'm going to go ahead and derive this. I'm going to derive it implicitly, which means I'm going to take the derivative with respect to x on both sides. So the derivative of sine, of course, is going to become cosine of y. Then, chain rule, the derivative of y is going to be 1 dy dx. On this side, the derivative of x is just 1. So dy dx, so if I need to find the derivative, or y prime, dy dx is going to be 1 over the cosine of y, which is also known as the secant of y. The secant of y, now I want this in terms of x though, not y. That doesn't help me. No problem. The secant of y is adjacent over hypotenuse. Cosine is adjacent over hypotenuse, so secant of y is going to be hypotenuse over adjacent. Hypotenuse, this is the adjacent, so the hypotenuse is going to be 1. The adjacent side is going to be the square root of 1 minus x squared. And I got that because the secant of y is just the ratio of the two sides. So I can substitute. Now we have the derivative of sine in terms of x. So the derivative of the arcsine of x is going to be equal to 1 over the square root of 1 minus x squared. There you have it. Pretty ingenious, huh? I'm impressed. What we did is we just took the inverse operation here to the derivative of something we knew we could do, and we implicitly derived and then used our trigonometric substitution to work backwards. That's fantastic. I won't make you work for this one. The derivative of the arc cosine of x is negative 1 over the square root of 1 minus x squared. Same thing, only negative. There you go. Let's do this one right here. Arctangent of x. Well, that means tangent of y is equal to x. Y is the angle. The ratio of the two sides, opposite over adjacent. That's going to give me y. The opposite side is x. The adjacent side is 1. Which means the hypotenuse is going to be square root of x squared plus 1. So now that I've got my triangle set up, let's go ahead and derive this. The derivative of tangent is secant squared of y, chain rule. Derivative of y is going to be dy over dx. And the derivative of x is just 1. Once again, what we did there is we took the tangent of y is equal to x, and we derived both sides. Only we did it implicitly. So that means dy over dx is going to be 1 over secant squared of y. Well, we know secant's really just 1 over cosine, so we have 1 over the cosine squared. So this is really just the cosine squared of y. So dy over dx, well, let's just find the cosine of y and square it. The cosine of y is going to be adjacent over hypotenuse. But it's cosine squared, so that means dy over dx for this is going to be 1 over x squared plus 1. There you go. The derivative of the tangent, arctangent of x, is 1 over x squared plus 1. Writing it slightly differently for you, just so we have some consistency. What's the derivative of arc cotangent, you say? Negative 1 over x squared plus 1. I won't make you earn this last one. The derivative, if y is equal to arc secant of x, the derivative is going to be 1 over the absolute value of x, square root of x squared minus 1. So naturally that means if y is equal to the arc cosecant of x, the derivative of that is going to be negative 1 over the absolute value of x, square root of x squared minus 1. So anytime you're dealing with the cosine, cotangent, or cosecant, the derivative is the same as the other one, only negative. It's just the opposite. All right. So now that we know these derivative formulas, we can use them and actually find the derivative. So what if y is equal to arctangent of x? Arctangent of 4x plus 1. Got to find y prime. Well, y prime means I'm going to have to, now if I remember the formula, it's 1 over x squared plus 1. The x in this case is the 4x plus 1. But by the chain rule, I got to take the derivative of the inside times 4. Now that right there is my answer. But what if I can't remember the formula? You all know Mr. Kuhne has a really, really bad memory, and so I often have to go through the whole process again. So, let's do that. I can do the whole thing I just did in the last one over again. So the tangent of y is equal to 4x plus 1 all over 1. So that means y, so that means when I draw my triangle here, this is going to be 4x plus 1. This is just going to be 1. This is going to be the square root of 4x plus 1 quantity squared plus 1 squared. Now I could work that out if I really, really want to. No, I don't. Anyway, I'm going to go ahead and derive this now. The derivative of this is of tangent is secant squared of y dy dx. The derivative of 4x plus 1 is just 4. So that means dy over dx is equal to 4 times 1 over secant squared of y. Secant squared, of course, being hypotenuse over adjacent, because cosine is adjacent over hypotenuse. So we're going to have hypotenuse over adjacent, but it's 1 over secant squared, so it's really just adjacent over hypotenuse. We're right back at cosine. So dy over dx is going to be 4 times 1 over the square root of 4x plus 1 squared plus 1 squared. But all this is squared, and that's going to give us the exact same thing we had just by memorizing the formula. So if you can remember the formula, that's great. Use it. That's easier. If you can't, work it out again. Same thing for this one, arc sine. Well, if I remember my arc sine formula, I would know that the arc sine formula is 1 over square root of 1 minus x squared. But it's not x squared in this case, it's whatever's inside the parentheses. So e to the 4x squared. Chain rule. Derivative of e to the 4x is e to the 4x. Chain rule again, got another link in the chain there. Got a function and a function and a function. Derivative of 4x is just 4. So in this case, y prime is going to be equal to 4e to the 4x all over the square root of 1 minus, I'm going to go ahead and simplify this. If I square 4x, if I square e to the 4x, I'm just multiplying those, so it's going to be e to the 8x. And that's my answer. But what if we couldn't remember it? No problem. The sine of y is equal to e to the 4x. Once again, if we can't remember the formula, we can always work it out just by making triangles. All you gotta do is draw a triangle. So here's y. This is gonna be over 1. Sine of y is equal to e to the opposite, e to the 4x, or the hypotenuse, which is 1. Which means the missing side is going to be 1 minus e to the 4x squared, or 8x. Now that I've got this all set up, let's hit both sides with a derivative. Derivative of sine is cosine of y, dy dx. Derivative of e to the 4x is 4e to the 4x. So dy over dx is going to be 4e to the 4x times 1 over the cosine of y. Cosine of y, adjacent over hypotenuse. But it's 1 over cosine, so it's hypotenuse over adjacent. Hypotenuse, which is 1, over the adjacent, which is the square root of 1 minus e to the 8x. Amazingly, we get the same thing. Same thing. How does that happen? It's math. Last problem. We have to find the derivative of y is equal to the cosine of the arcsine of x. Am I going to do the chain rule? Take the derivative of the inside, take the derivative of the outside, leave the inside, take the derivative of the inside, and multiply? No, I'm not. Why not, you ask? Because I can draw a triangle. So let's draw this triangle then. Now remember, cosine is always of an angle. We're going to call this inside angle here theta. And theta is the arcsine of x, which means the opposite side is x. The hypotenuse is 1. After a little Pythagorean theorem, I know the remaining side, the adjacent side, is 1 minus x squared. Now I got to take what is the cosine of this angle. The cosine of this angle is adjacent over hypotenuse. So wait, Mr. Kuhne, are you telling me this function is really just square root of 1 minus x squared? Is that possible? Yes, it is. Now, that is a whole lot easier to derive than all that. I can deal with this. Y prime is equal to, rewrite this first, 1 minus x squared to the 1/2. So derivative of this 1/2 times 1 minus x squared to the negative 1/2. Chain rule. Derivative of the inside here is going to be negative 2x. So y prime is really just going to be, those twos cancel out. This negative puts it on bottom. Square root of 1 minus x squared, negative x. That's a whole lot easier than trying to do the other one. All because we can draw a triangle. Whole lot easier. So there you go. If you can't remember the formula, draw a triangle. That's all you got to do. Just take the inverse operation, set up your triangle with the ratio of the sides, implicitly derive, go back and use a substitution. Now, if you can't do this and you can't remember the formulas, then I don't know what to tell you. You're up a creek without a paddle. I don't know. Otherwise, though, all you have to do to solve these, set up a triangle or remember the formula. Now, for the purposes of the AP exam, you normally won't see anything this tough. Could there be something this tough on Mr. Kuhne's test? Yes, there could. But will you see anything this excruciating on the AP exam? Probably not. There'll probably be something just like x over 2 or 3x in here. Nothing too tough. Thanks for watching.